All right, ladies and gentlemen, welcome back to another fun adventure in our Data and Statistics unit. This is going to be dubbed Data and Statistics Unit Part 2, Day 1. Yesterday, you guys had an Edulastic that kind of summarized the first half of our data and statistics unit. And because the unit is somewhat large, we break it into two parts. This is part two, and part two is largely going to be focusing on data displays. So in the first part of the unit, we talked about one data display in particular, and that was dot plots. But now this part of the unit, we're going to go into a couple other data displays. So just so you have an idea of what this unit looks like, we look at a couple things. First, today, we'll be talking about something called stem and leaf plots. From there, we'll hop into histograms, which are interesting. We'll then talk about the shapes of distributions of data displays, which that might not make sense to you right now, but it will soon. From there, we will talk about how to choose appropriate measures when you are creating and looking at data displays. And finally, we are going to look at one of my favorites, box and whisker plots, but that's where we will end this unit. We are starting this part of the unit with stem and leaf plots, so without further ado, let's go there. Stem and leaf plots are a little bit weird, but they're still a data display that we're going to learn this year. We're not going to spend too much time on them, but we would like you to be able to, number one, be able to create a stem and leaf plot from a set of data. So I will be going over how to create a stem and leaf plot. Secondly, we would also like you to be able to answer questions about a data set based on a given stem and leaf plot, which I will also go over in today's lesson. I will show you a already created stem and leaf plot and ask some basic questions about the data. So those are the two things that you should be able to accomplish after today's lesson. First thing is, what the heck is a stem and leaf plot and why such a goofy name? So I was going to attempt to draw, but I practiced beforehand and it looked pretty bad, so I'm not going to do that. Instead, I just took a piece of clip art from online of a stem with some leaves on it. In case you've never seen a stem with leaves, this is approximately what it looks like. The stem is in the middle, and then off of it are coming a bunch of leaves. The reason a stem and leaf plot data display is called that is because it somewhat reminds people of a literal stem with leaves coming off of it. I'm going to first show you a stem and leaf plot, and then we'll talk a little bit about what it is. This is a stem and leaf plot. There's not a lot going on here, but you can see there are two columns in this plot. One of those is called the stem, the other is called the leaf, and you'll also see there's a key down here. So this key tells me that the 2 line 0 really stands for the number 20. So you could infer that maybe 3 line 1 means 31, and then that means 34, 38, 42. So here I'll write out what a stem and leaf plot is, and then in case you take notes, and then we'll talk a little bit more about it. All right, so in case you're a note taker or need to visualize what I'm saying, a stem and leaf plot is a data display that uses the digits of all the data values to organize the data set. So like I said, we previously did a data display called a dot plot. That took each data value and represented it with a dot on a plot. This instead takes each of those data values and organizes it by its digits. And it breaks each data value into a stem. The stem is the first digit or digits, if you had like a 3-digit number, that are to the left. And the leaf, which is the digit or digits, if it was a 3 or 4-digit number, that are on the right. So that's what a stem and leaf plot is, but I think it's kind of confusing unless you actually just use an example. So that's what I'm going to do. I'm going to use this example here to create a stem and leaf plot with you, and hopefully that'll help clarify things a little bit. So the example I created here, a non-sports example, was a cell phone service provider like Verizon or AT&T, for example, is analyzing the length of cell phone calls from some of its customers. So in this table, that we have right here, you can see that they've already taken 12 different phone calls, all from the month of July. And there's a 55-minute phone call, a 3-minute phone call, a 6-minute, and so on. And they want to analyze these phone calls. So we are going to do that by making a stem and leaf plot of these 12 phone calls. And here is how you create a stem and leaf plot. The first thing you need is you need to create a table. Very simple. Line, line, with a left side and a right side. And you call the top left your stem and the top right the leaf. Stem and leaf plot. All right. Now, it's super helpful if, as a first step or like a pre-step, you order your numbers from least to greatest. Because one feature of a stem and leaf plot is that everything is ordered from least to greatest. So it's not totally necessary, though it's helpful if you take a minute and order these from least to greatest, which I'm going to do just to make sure I don't miss anything. Feel free to do so on your own as well. All right, so now that we have the data ordered from least to greatest, we are now going to take these numbers and we're going to put them into the stem and leaf plot. Now, the data that doesn't really matter in this chart is the dates. That's not what we're organizing. We're talking about the minutes here. So that's what we're going to focus on. That's why I ordered that from least to greatest. And you can see the numbers range from 2 minutes all the way up to 55 minutes. So what we're going to do is we're going to, since these are all 2-digit numbers, we're going to make the stems all the first digits and the leaves are going to be the second digits. So I'm going to start by capturing all of the stems. The stem ranges from numbers with no tens place all the way up to fives. So I'm going to order those from least to greatest. So 0 in the tens place, 1, 2, 3, 4, 5. So really haven't done anything yet other than realize that I've got numbers with no tens place to numbers with a 5 in the tens place. And then I'm going to work on ordering each of the leaves that match each stem. So the first numbers are 2, 3, 5, and 6. Those have no tens place. They're going to be ordered from least to greatest in the leaf section. So 2, 3, 5, and 6. And those are my first 4 phone call logs. The next are numbers with a 1 in the tens place. So I've got things ranging from, let's see, 10, 14, and 18. So I'm first going to put in my 10, 14, and 18. All right, the next set is going to be anything in the 20s, which I've got 2 23s. So here's where I'm going to point something out that's important. Even though the number 23 occurs twice, you don't just represent it once. There are 2 23s, so I'm going to show that. 23, 23. There's 2 of them. Show them both. You're representing every single number in this plot. All right, next would be things that are in the 30s, and I do have 2 of them, 30 and 36. So 30 and 36. You'll notice that I put a stem here for the 40s, even though there are no 40s here. This is an important point. You always include stems even if they don't have leaves. The reason for this is stem and leaf plots are a great way to see how your data is distributed, where all of the numbers fall, the range of them, and more specifically, a stem and leaf plot gives you additional information that something like a dot plot doesn't give you. A stem and leaf plot can show you, for example, how many things are within a certain tens. So like, how many 20s are there? How many 30s are there? How many things are in the 50s? And it's important to see that there's nothing in the 40s. That might represent something interesting to the person who's analyzing the data. Like, why is that have nothing? Why is there a gap in the data there? So please make sure if there is a stem that doesn't have a leaf, you still should include that in your stem and leaf plot. Anyways, to finish things off, the last data value is that lonely 55. And this also, just like looking at the stem and leaf plot, 55 you could maybe call an outlier. Most things seem to be up here in the no 10s to 10-minute range. And there's not a lot up here, and then there's this 155. So this might stick out to whoever's analyzing this information and might tell them something. Anyways, this is how you create a stem and leaf plot. I'm going to quickly go through some of the important points. The first thing I've already said is make sure you include stems without leaves. Secondly, you're ordering things from least to greatest. Both the stems are ordered from least to greatest and the leaves are vertically ordered least to greatest. Also, you are including a digit even if it occurs twice, like 2323. Every data value should be captured here. If I count the leaves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there are 12 phone calls, and I can see that there are 12 data values there. One big thing that I am missing, and I'm going to go put it in there now, is a key. You should always have a key so that someone knows exactly what this stem and leaf plot represents. So I'm just picking one random number, 14, and the 1 separated by the vertical line there, and the 4 represents the number 14. Why do you need a key, some of you might be asking? Well, what if we were talking about numbers that were, I don't know, decimals? What if this actually stood for 1.4? Or what if you had numbers in the hundreds or whatever? I could say a ton of things. The key is very important because it lets the reader know what type of numbers they are analyzing and looking at. And now the last example for today. Here is an already created stem and leaf plot, and we're going to focus on how to interpret this. This particular stem and leaf plot shows student quiz scores. We can see from the key, just like I had said before, this is decimal values. So this person, for example, earned a 6.6. This person scored a 9.2, a 9.9, an 8.1, a 10.0. So this is not two-digit numbers. These are decimal values. Anyways, let's go through some of the questions here. Fairly simple, but let's make sure we've got it. How many students scored less than 8 points? Well, that's not too hard to figure out. It's nothing in this column or above because these are all 8.1s and above. So that means it's got to be 7.0, 7.5, 7.7, 7.8, and that 6.6. So that's 1, 2, 3, 4, 5. 6 students scored less than 8 points. That would be your final answer there. All right, next question. How many students scored at least 9 points? So I'm looking for 9.0 and above. That would be the student who scored 9.0, the person who scored 9.2, the person who scored 9.9, and the person who scored a 10. That would be 4 students. Again, we're just going over how to read and interpret a stem and leaf plot. Not too hard. Last question is a little tricky. It's a little open-ended, and you have to make sure you understand what it's asking. How are the data distributed? So when we talk about the distribution of data, we're talking about where do values fall in this data set. In this data set, how is it distributed? One of the things I would say is that scores range from 6.6 on the low end to 10.0 on the high end. So when you're talking about the distribution of data, I think one important thing to consider is its range. Where do the scores range from? We go all the way from a 6.6 to a 10.0. Beyond that, Another way to talk about the distribution is where do most of the data values occur? Even though the scores have that range, I would say there are a few that are low, like the 6.6. There's a few that are high, like that 10.0, the 9s, but most of the scores are in the middle. So how is the data distributed? Most fall within. And now let's pick a range. Where do most of them fall? We can see that clearly. Most of them are in the 8s. So most fall within 8.1 to 8.9. There are some outliers. There are some things that are super typical. Not a lot of people are getting 6s and 10s. Most are falling within that 8.1 to 8.9. So when you're asked how are data distributed or talk about the distribution or describe the distribution, this is one simple way to do it. Give the range, and then from there, tell where most of the scores fall, which is very easy to see from a stem and leaf plot. Anyways, that is your lesson for today. Not too hard. Pay attention to the details, though. Try to perfect this lesson in the practice. If you have questions, reach out. Enjoy. Happy day.